Good day. We are Group 7 and we will be presenting about the glycol dehydration process, its process flow diagram, piping and instrumentation diagram, the instruments involved, the considered parameters, and the edge of this process.
I'm Rosette P. Perez and I'm gonna be discussing about glycol dehydration. Glycol dehydration is a process used to remove water vapor from natural gas and natural gas liquids. When natural gas is extracted from the ground, it often contains water vapor, which can cause various operational issues if not removed. The glycol dehydration process employs glycol, a group of organic compounds to effectively absorb water from natural gas. Dry glycol absorbs water through heating and separation steps, generating lean glycol that may be recycled and guarantees that water and hydrocarbons are effectively removed. Next slide po.
So I am Jeranin G. Ermita and I will discuss the PNID and instruments of our process. So now we'll present the piping and instrumentation diagram of the glycol dehydration process. A PNID for a glycol dehydration process typically includes various symbols and notations to represent the equipment, instrumentation, piping, and control devices involved in the process. Next slide po. So we can see from the figure the different instruments and components in our glycol dehydration process. So there are a total of 7 loops in this figure, wherein loop 1 is the contactor tower liquid level control, loop 2 is the rich or wet glycol flow control on main line, loop 3 is rich or wet glycol pressure control on main line, loop 4 is post-reflux column temperature control, loop 5 condensate flow control on skimmer, Loop 6 is the wet or rich glycol flow control on skimmer, and loop 7, which is the reflux column wet or rich glycol temperature control. So the glycol dehydration system operates through a meticulously designed network of 7 control loops, each precisely calibrated to uphold specific parameters and enhance the overall efficiency of the process. These loops, ranging from overseeing liquid levels in the contactor tower to regulating temperatures in the reflux column and skimmer, play a pivotal role in maintaining a continuous and controlled processing of wet natural gas. By incorporating an array of valves, converters, controllers, and alarms, these loops not only act as a safeguard against deviations but also significantly contribute to the safety and reliability of the glycol dehydration process. This underscores the presence of a sophisticated and well-coordinated control system dedicated to the treatment of gas. Next slide po. So here are the different instruments that were used in our glycol dehydration process. They serve as to convey information about the status and conditions of the process, enable control actions, and enhance the overall safety, efficiency, and reliability of the system. So first is the pressure element. The purpose of this is they ensure safety by detecting and addressing abnormal pressure conditions, contribute to the optimization of the process through real-time monitoring and control, and ultimately uphold the reliability of the glycol dehydration unit in producing dry natural gas. Next is the pressure gauge. So the pressure gauge are essential instruments used to measure and display the pressure of fluids in a process system. So they provide operators and engineers with real-time information about the pressure conditions within a vessel, pipeline, or other components of the system. Next is the pressure transmitter. So the pressure transmitter is designed to measure pressure at specific points, typically in vessels or pipelines, and they convert this pressure information into an electrical signal. This signal is transmitted to a control system or operator interface. The primary purpose of the pressure transmitter is to provide real-time and accurate data on pressure conditions. Next slide po. Next is the pressure control valve, which serves a crucial purpose in regulating and maintaining optimal pressure levels at key points within the system. This valve is strategically placed to control the flow of fluids, ensuring that the pressure remains within specified ranges to facilitate efficient and safe operation. Pressure alarm high. So the purpose of this of the pressure alarm high in the glycol dehydration process is to provide an early warning of potential issues that could compromise the safety and efficiency of the system. Next is the pressure alarm low. So just like the pressure alarm high, pressure alarm low is designated to alert operators or control systems when the pressure at a specific point fall below a predetermined low pressure threshold. Next slide po. Next is a pressure converter. So the purpose of a pressure converter is to facilitate the seamless integration of pressure measurement and control systems, ensuring accurate and consistent pressure readings throughout the system. So a pressure converter, often in the form of pressure transducer or transmitter, wherein our process is a transducer, serves as a crucial interface between the process varying pressure conditions and the instrumentation and control systems. Next is a temperature converter. So the purpose of a temperature converter in a glycol dehydration process is pivotal for ensuring accurate and consistent temperature measurements across the entire system. In glycol dehydration units, precise temperature control is fundamental for the effectiveness of the process. The temperature converter plays a crucial role as a bridge between different temperature units or measurement systems, ensuring that the data from various temperature sensors or instruments can be uniformly interpreted and utilized. Next is the temperature element or sensor. So the purpose of a temperature element in a glycol dehydration is to provide accurate and real-time temperature measurements, facilitating the control and optimization of the absorption and regeneration phases. Next slide po. So thermowell, so the purpose of the thermowell in a glycol dehydration process is to provide a protective enclosure for the temperature sensors, shielding them from corrosive and harsh process conditions. This protective function extends the lifespan of the sensors, allows for convenient maintenance, and enhances the safety and reliability of the glycol dehydration unit by preventing potential leaks and ensuring accurate temperature measurements over the course of its operation. Temperature control valve, so the purpose of this is in a glycol dehydration process is to regulate and control the temperature of the glycol within the system. The temperature indicating controller for purpose so is it combines the functions of a temperature indicator and a temperature controller in a single unit. So a temperature indicating controller in a glycol dehydration process is to monitor, control, and optimize temperature conditions at critical points within the system. Next slide po. Next is the temperature alarm high. So the purpose of this is to provide an early warning in situations where the temperature rises beyond safe or optimal operating limits. As for the temperature alarm low, the purpose of this in a glycol dehydration process is to provide a crucial safety net, alerting operators to deviations from specified temperature parameters. By doing so, it enables rapid responses, safeguards the efficiency of the dehydration unit. Next is the level converter. So the purpose of a level converter in a glycol dehydration process is to standardize and facilitate communication between various level measurement devices. Next slide po. Next is the level indicating controller. The purpose of the level indicating controller in glycol dehydration is to provide accurate and real-time information about glycol levels, enabling operators to actively control and maintain the desired liquid levels. Next is the level control valve, and the purpose of this in a glycol dehydration process is to regulate glycol circulation, ensuring precise control over liquid levels in both the absorption and the regeneration phases. By facilitating controlled glycol flow, the valve contributes significantly to the efficiency, safety, and reliability of the glycol dehydration system, ultimately influencing the quality of the treated natural gas. Next slide po. So next is the heat exchangers. The purpose of the heat exchanger in a glycol dehydration process is to enhance the efficiency of water vapor removal by optimizing temperature conditions during absorption and regeneration. By facilitating the exchange of heat between process steams, The heat exchanger plays a pivotal role in ensuring the reliability, energy efficiency, and sustainability of the glycol dehydration unit. Next is the pneumatic valve. The purpose of a pneumatic valve in a glycol dehydration process is to provide responsive and accurate control over fluid rates, particularly in regulating glycol circulation during absorption and regeneration. Their role in maintaining safety, reliability, and process efficiency makes them indispensable components in ensuring the successful treatment of natural gas in glycol dehydration units. On the other hand, the purpose of the pressure regulator in a glycol dehydration process is to control and stabilize pressure levels, ensuring optimal conditions for absorption and regeneration. So, by preventing pressure fluctuations, the regulator plays a crucial role in enhancing the safety, efficiency, and overall reliability of the glycol dehydration unit, ultimately influencing the quality of the treated natural gas. Next slide. Next is the resistant temperature detector or the RTD. The purpose of the RTD in a glycol dehydration process is to serve as a critical temperature sensor, ensuring that absorption and regeneration phases occur at optimal temperature levels. Mainline, so the purpose of mainline is it orchestrates the sequence of events that defines the glycol dehydration process. It serves as a vital channel for the controlled and optimized flow of natural gas, enabling efficient water vapor removal and contributing to the overall reliability and effectiveness of the glycol dehydration unit. The proper functioning of the main line is essential for ensuring a consistent, high-quality output of the hydrated natural gas, meeting industry standards and facilitating downstream processes. Next is the electric signal. The purpose of electric signals in a glycol dehydration process is to provide real-time data about key process parameters, enables precise control of various elements, and contribute to the overall safety and reliability of the system. Next slide po. So next is the pneumatic signal. So the purpose of pneumatic signal in a glycol dehydration process is to facilitate the precise control and modulation of various components, particularly pneumatic valves, in response to commands from the control system. Lastly is the capillary tube, wherein its purpose in a glycol dehydration process is to regulate and control the flow of glycol, ensuring optimal absorption of water vapor from the natural gas. Its role as a metering device is instrumental in maintaining a consistent glycol to gas ratio, ultimately influencing the efficiency and success of the glycol dehydration unit in treating natural gas.
Good day. I am Alison Briones, and I will be discussing the parameters as well as introducing the process flow diagram of the glycol dehydration process. The glycol dehydration process relies on four parameters, namely pressure, temperature, flow rate, and liquid level, with each playing a crucial role in maintaining the efficiency and effectiveness of the system. A delicate balance and precise control of each parameter is necessary to achieve said effectiveness, as well as the desired outcome of dehydrated natural gas for processing and transportation. First, pressure is a pivotal parameter in the process and is typically controlled at different points of the system to optimize conditions for glycol circulation, absorption, and regeneration. Pressure helps maintain the desired flow of wet natural gas and glycol within the contactor tower. It is crucial to have adequate pressure for ensuring effective gas and liquid interaction, thus promoting efficient water vapor absorption by the glycol. Next, temperature is fundamental to the process as it influences the efficiency of moisture removal and glycol regeneration. Certain processes of the Certain sections of the process require specific temperature conditions to achieve optimal results. For instance, heat exchangers help regulate temperature to prevent hydrate formation in the natural gas itself to ensure smooth transportation. Additionally, temperature control helps with the separation of water vapor from the rich glycol during the regeneration process within the reflux column. Next, flow rate control is critical to the process as it helps maintain the balance between effective moisture absorption and glycol regeneration. It is regulated to optimize transportation of glycol for regeneration in the reflux column. Additionally, Consistent and controlled flow rates contribute to the overall stability and efficiency of the process. Lastly, to ensure proper contact between wet natural gas and glycol within the contactor tower, liquid level must be maintained optimally. And this is crucial for effective water vapor absorption by the glycol. The level control loop, which involves a level indicating controller and level control valve, help adjust the liquid level so as to prevent issues such as carryover or insufficient contact, thus optimizing the absorption capacity of the glycol. Next slide, please. Now we will present the process flow diagram of the glycol dehydration system. Next slide, please. As seen, the figure is a less detailed process of the glycol dehydration, but it still shows the key components and processes of the dehydration. From the figure, we can see that there are three possible flows of the process that can happen. Next slide, please.
I'm Jean Clarence P. Hernandez. I'm here to go over the highlighted portions in the process flow diagram 1, which are marked in yellow, as well as the highlighted sections in process flow diagram 2, marked in pink. So let's begin the discussion of process flow diagram 1. In the glycol dehydration process cycle, as the wet gas stream enters the contactor tower, the glycol absorbs water and exits the tower. The rich glycol from the contactor tower is directed to the reflux column via the gas or glycol heat exchanger, resulting in the production of lean glycol. After after passing through two glycol heat exchangers, the lean glycol is returned to the system by the glycol circulation pump. The cycle persists as the lean glycol moves through the gas or glycol heat exchanger, ultimately re-entering the contactor tower. This repetitive process effectively ensures the conversion of natural gas into a dry state, meeting specified requirements. All right, we have completed the description of process flow diagram 1, and now we move on to the process flow diagram 2. Okay. As indicated by the highlighted pink section, the cycle initiates from the reflux column, where the rich glycol is introduced. Instead of exiting the drum as lean glycol, it departs as rich glycol and proceeds to the second glycol heat exchanger. Following a heat exchange with a lean glycol, the rich glycol undergoes separation of its components in the skimmer. Subsequently, it passes through a suck filter and charcoal filter to eliminate additional impurities and hydrocarbons. After this, it flows through the first glycol heat exchanger before returning to the reflux column. This cyclic process continues until the product reaches the required standard of becoming lean glycol. That concludes the discussion of both flow diagram 1 and 2.
I am Arabella Malabag and I will be presenting the process flow 3. The third possible flow of the glycol dehydration process is after the rich glycol came back to the contactor tower from the first and second flow, the glycol will absorb the water from the incoming wet gas and the dry gas will now proceed to the gas glycol heat exchanger, where the dry gas will exchange heat with the rich glycol, so the dry gas will be cooled before it goes out of the dry gas outlet. The dry gas is the main output of this process, and the process repeats until the desired output is achieved. Next slide, please. Why is this process efficient? This process is efficient because of the utilization of gas glycol heat exchanger before the rich glycol enters the reflux column. The rich glycol is preheated in the gas glycol heat exchanger, so when it enters the reflux column, the elevated temperature increases the likelihood of efficient evaporation of moisture during the reboiler phase. This preheating not only accelerates the process cycle, but also serves as a cost-effective measure by eliminating the need for additional expenses associated with heating and cooling the dry gas and lean glycol passing through the gas glycol heat exchanger. In essence, this thoughtful integration of the gas glycol heat exchanger optimizes the energy usage within the system, making the entire glycol dehydration process both faster and economically advantageous.
Next slide po. So for our conclusion, in the natural gas industry, glycol is used in the primary process known as glycol dehydration, which extract water vapor from extracted natural gas. This is necessary to keep natural gas clean for consumer consumption and transit, avoid hydrate formation, and prevent corrosion. It is also essential in petrochemical refining and other industries where the removal of water vapor is critical in for product quality and safety. Glycol dehydration process is a cornerstone in the natural gas sector, addressing challenges associated with water vapor to ensure the smooth flow of gas and maintain the integrity of infrastructure. Its cyclical nature, involving the continuous regeneration of glycol, makes it an efficient and widely employed technique in various industries, and therefore, natural gas operations must remain dependable and efficient, so glycol dehydration techniques must be continuously applied and improved. And that would be all for our presentation about glycol dehydration process. Thank you.